Network Location Awareness. The Network Location Awareness Service allows applications that make use of network resources to identify available networks and retrieve up-to-date network information. Through this service, applications are able to choose the network based on the information that NLA has retrieved that will suit its tasks best. It effectively eliminates the need for applications to randomly choose just any network connection. The Network Locations Awareness Service has made it easy for software developers to make their programs network aware and thus more user-friendly. How
To access to this service, first you need to click Start, then Run. Key in services.msc and then press OK. After a few seconds, the services dialog will then appear. Scroll down in the list of services available on your local system and look for Network Location Awareness. The default startup type of this service is manual and is thus the recommended startup type. Setting the service's startup type to manual is particularly important if your computer is connected to a network or networks. If you move between different networks, if you use software that is network dependent, or if you have Internet Connection Firewall or ICF or Internet Connection Sharing service enabled. Only disable this service if your computer is hooked up to a network. You do not use any software that is network dependent or if you have ICF or ICS enabled. So that ends. Thank you.
network location awareness works? Windows detect the following network location types. First, the public, which by default, the public network location type is assigned to all networks when they are first connected. A public network is considered to be shared with the public with no protection between the local computer and any other computer. Next is the private, in which the private network location type can be manually selected by a local administrator for a connection to a network that is not directly accessible by the public. This connection can be to a home or office network that is isolated from publicly accessible networks by using a firewall device or a device that performs network address translation or NAT. Last is the domain, in which the domain network location type is detected when the local computer is a member of an Active Directory domain and the local computer can authenticate to a domain controller for that domain through one of its network connections. The following figure shows a simplified corporate network connected to the Internet. Corporate networks are made up of multiple subnets and make available resources such as printers, mail servers, credential servers, and etc. Typically, users can roam from subnet to subnet within the same network and still have access to the same resources, use the same credentials, and must abide by the same policy. Thus, it is useful to identify the entire corporate network. NLA does this by assigning a unique network ID for each domain corresponding to a DNS domain name suffix. However, a domain-wide definition of a network may be too broad for some applications. For example, a company may wish to apply different policy for subnets. In such cases, the default gateway may be used to further qualify the network. NLA does this by appending the network ID with a unique link ID based on the default gateway. The next figure shows home networks connected to the Internet. In general, a home network is connected to the Internet via an Internet service provider network such as those provided by broadband service providers. Many homes may use the same ISP and thus share the same domain name. As a result, applications may need a greater precision than a domain-wide network definition. Digital subscriber line or DSL and cable modems typically act as network address translators. As a result, their addresses can be used to uniquely qualify the user's network. NLA uses the address of the user's DSL or cable modem as the link ID. This section illustrates how applications can use NLA through a case study of a simple mail client or SMC application. SMC is a single-threaded application with 5 states. First is the initialize, which initializes the mail client and retrieves the cached mail from the local mail store. Second is contact mail server, which attempts to contact the mail server via the internet. Third is the download, which downloads mails from the mail server via the internet. Fourth, the idle, which waits until the idle timer has expired. And last is the stop, which caches the mail from the mail server in the local mail store.